All right, gang. Mass 6610. Going to try something new here. I've tried this out in a couple of videos with my Mass 6500 folks. And you can keep me posted whether you like it or not. What I typically have used is I've used my iPad with Dosery and screencasted anything that I needed to write that way. Those of you that were in the Straight A Fund or Straight A Grant, whatever the heck we call that thing, with Shawnee State, remember the very first day, the presenter talked about a Ziggy HD, where you could project what you write on a paper onto your screen and do screencasting. Well, that's what I'm attempting to do. So I don't know. I kind of like it, and I kind of don't like it. So one thing you get to see like big ugly picture of my arm from time to time, because I haven't figured out a way to. I wish I was left-handed, because if I was left-handed, it would be easier to write, but I'm not. So we'll go with it. Guys, the things I want to talk to you about in this one, this is an extra video. It's going to be a short video. But there are 4 things that I wanted to connect with you about. Okay? First thing is I want to give you an update on assignment number 1, which has been graded. Second thing I want to give you is an update on my office hours. I've changed the way that I'm doing that. It's much more of a liberal policy. Next thing I want to do is show you some new stuff that I found with G-Power. It's really not anything new. It's just, well, it's going to be kind of maybe new to you. I'm not sure. So I'll explain that at the proper time. And I want to talk to you about assignment number 2. It's been posted, and I forget the due date, but I think maybe it's a Monday in October at 8 a.m. But that's clear. It's been posted. Guys, assignment number 1, what I want to say about it is good job for the most part. The only thing that, that had a couple people that didn't turn it in, which was a little strange, but, the only thing I can say about, if your schedule's just too tight and you just can't handle 2 graduate level math courses, then you need to drop one of them. But that's just a decision that each person has to make, because we're all, we just all have different things going on. For example, I've been at Shawnee 20 years, and this is my busiest semester ever. But I got 4 preps. 3 of them are graduate courses, and 3 of them are courses I've never taught before. And along with being graduate director and being on seems like every committee coming and going, it's just really busy. So enough of about me. Assignment number 1, 2 things. One thing, effect size and power, which I want to talk to you about there in the third bullet. But the next thing, in terms of reporting results, guys, remember that when you report results, you report the move that over where you can see it. You report the test statistic, the letter that stands for the test that you conducted. The next thing is your degrees of freedom, and the next thing is your test statistic value. So if you're conducting an ANOVA, you're going to do an F test. Your degrees of freedom, let's just say they're 2 and 13. And then your value. If you're doing a t-test, whatever it may be. Now, some of you are sitting there saying, well, that's what I did. I know, I'm not talking to you. I'm talking to the 2 or 3 people that didn't do that. So guys, put that on your radar, and from here on out, make sure that you report these things appropriately. Now, this is going to be these results will be presented in sentence or paragraph form, so you're going to kind of talk it through. But this is the statistical results that are validating what you're saying in words. One more thing, in terms of reporting p-values, I don't know if I've told you guys this yet or not, but there's a way that we report p-values in research. And at the end of the day, it depends on one of 4 classifications. Guys, if your p-value is above 0.05, then you report it. So guys, if something happens where you have a p-value of 0.31, then you report it as 0.31. A lot of you reported greater than 0.05 and stuff. That's not the way we do it. The next thing, if you have a p-value that's less than 0.05, and actually I should say down here, greater than or equal to 0.05. But if you have a p-value that's less than 0.05, but still greater than 0.01, then you're going to report this as p less than 0.05. Guys, if you have a p-value that is .01 or less, but not less than 0.001, then you're going to report the p-value as less than 0.01. And if you have a p-value that's, actually, yeah. Yeah, I put the strict inequality in there, and the chances of you getting a p-value of 0.001. I'm not sure that's even right. I'm not sure whether we should go, guys, fake it if it happens. And it's not going to, so it's not going to be an issue. But anyway, in terms of the strict inequalities, this is the way that we would report p-values. Office hours. Doing something new on office hours in that I'm a lot more available on Google Hangout. Primarily the reason I'm doing it, is because I want to be there if you need help. Secondly, the reason I'm doing it is for my Math 6996 students who are in the process of trying to come up with research project topics and get ready to write a research proposal, and then ultimately write the first 2 paragraphs of their research of their final paper. Now, a lot of this stuff I can get on a video like this and just do the talking, but there has to be a lot of interaction. And I have people in that class that live a couple hours north of Columbus, so it's it's easier to do it this way. So guys, anyway, standard office hours, just in case you're hanging around Shawnee State University campus, I'm always available in my office from Tuesdays and Thursdays from 3 o'clock to 5 o'clock. So if you're on campus, stop by and at least say hi. For the Google Hangout sessions, I'm trying to be available 3 hours a week on Google Hangout sessions. And the sessions that are pretty set in stone, I am always available Friday mornings from 8 a.m. to 8:45 a.m. And I try to be available on Wednesdays from 1:30 p.m. to 2:20 p.m. and from 3 o'clock p.m. Let's just call it 4 o'clock p.m. Now, I will tell you, contractually with Shawnee State University, I'm doing what I need to do right here. I'm doing this as extra. So if, for example, this session right here, what I'll typically do is I'll hang around for 20 minutes, maybe 30 minutes. If nobody shows up, then I'll shut this down. But if something like that happens and you need to meet with me at, say, 8:45 or 8:50, then just communicate to me. Just send me an email, send me a text, and just let me know what you need. These Wednesday sessions, Shawnee State has a thing about having meetings on Wednesday at 4 o'clock. Most semesters for me it's not a big issue, but this semester, because I'm so busy, with 4 preps and, I'm teaching Math 1500, which I've taught many, many times, but we're teaching it a different way. I'm teaching it using R, so I've kind of had to rewrite some of what I do for that. So enough complaining. So guys, these are the Google Hangout sessions that I'm available. On Wednesdays, if I do have meetings and I'm not able to be available, what I usually do is I add a session on a Friday afternoon from 3 o'clock to 4 o'clock. So just keep that in mind. But typically what I'll do is on a Monday morning, I'll send out an email, and I will start doing that next week for you guys, and tell you that, the time that I will be available on Google Hangouts. So guys, you got to set up an account. Look for me, join the session and go on. If you don't know how to do that, I actually found some pretty cool videos on YouTube. Just type in join Google Hangout session, and there's actually some very, very straightforward stuff on YouTube showing you how to do that. But it's really, really easy. Okay, and keep in mind too, there's a Google Hangout session is limited to 10 people. So with me, I'm able to take 9 more. So there could be a situation where you try to join and can't. So keep that in mind. All right, guys, let's talk about this G-Power. I've run into something that I knew, but it really didn't hit me until I was grading your all's assignments. When you get to effect sizes, there's lots of different types of effect sizes. We've run into, so far, Cohen's D. We've also seen eta squared. We've seen this. We've seen this, and so on and so forth. So there's lots of different R squared. But anyway, there's lots of different effect sizes. I think in one of the videos I illustrated something that was incorrect, and I want to bring this to your attention. Guys, some of you did this on the assignment. I didn't take off, but I want to correct that in this video. Let's say, for example, through just a couple of demonstrations here. Let's say that we conduct a matched pairs t-test. Now remember, a matched pairs t-test is where we take the same measurement on subjects, at 2 different points. And let's say, for example, that we end up having, 50 people that we've taken measurements on. And we have some sort of pre-measurement, and we have some sort of post-measurement, whatever those may be. And let's say that we find out that we have a mean difference of 3.2, and we have a standard deviation for the difference of 0.7. And we're in a situation where we'd like to take a look at the effect size, and we'd like to take a look at the power. And let me show you something that I think is pretty clever. If I go down here to G power, which, let me get rid of this. Go down here to G power, which I have up and running. Clearly the first thing I need to do is choose the correct test family. And wow, there's exactly what I need. So the matched pairs test. Now, the thing about it is you may have calculated an effect size using Cohen's D or R squared. R squared would be appropriate here because it's just our t-value squared divided by the t-value squared plus the degrees of freedom. But G power is requiring you to put in the effect size Cohen's DZ. So if we put in R squared here, we're going to create a post hoc power that's incorrect. So if you'll click this button, Determine, it's actually kind of cool because it opens up a little slide bar. And it gives you two options here for calculating the effect size DZ that it needs for this calculation. So for example, my mean difference, so I can do that here. My mean difference I said was 3.2. And the standard deviation for the difference I said is 0.07. And I can come down here to calculate, and I can see, yeah, this standard deviation is way too low. I'll tell you what, let's change the standard deviation I knew to 0.7 instead of 0.07. I'm going to change that over here because that was going to be a tremendous effect size. So I'd like to have something a little bit more reasonable. So if I calculate this, I can see that my effect size is 4.57. All right. So I'm going to come over here, and I'm typically going to run a two-tailed test. And I'm going to put in my effect size, which is the DZ, 0.457. This is Cohen's DZ. We have a 0.05, and guys, I'm in the wrong place. I need to do the post hoc. So let's run this again. So the effect size was 4.57. Total sample size, I think I said 50. Now, it's going to make the calculation of the power, which would... yeah, a lot of power. And the reason is because the standard deviation of the difference was so small. So let's go over here and make this something more reasonable. Maybe 1.9. That would probably be much more reasonable. So we got a calculation of an effect size of 1.68. That's what happens when you make up these things on the fly. And of course, I got a large sample size, and when you take multiple measures, as we're going to see when we study repeated measures design, we get a lot of power. So I'm still expecting a tremendous amount of power, which we actually get. So just keep that in mind. Something else. Let's say you were going to run a t-test, but you wanted to do between two independent means. Well, the same options exist. If we want to do a post hoc to calculate the achieved power given effect size and stuff. We can either calculate this when we have unequal sample sizes or equal sample sizes. Now notice when we do unequal sample sizes, it requires you to do the standard deviation sigma of the within each group. So it's trying to get you to do a pooled within standard deviation there, which you can easily get on R. Typically, we run these with equal sample sizes, and let me just show you how this actually works. Let's say, well, I don't know, whatever. Okay, so our effect size, and notice here it's using Cohen's D and not Cohen's DZ. So we have an effect size of 1.399. And let's keep it. We said we had equal sample sizes, so let's keep that. And guys, just run your power. So again, big time power. So if there does exist a difference between the two groups and the means of two groups, then we should be able to locate, to find that difference. We have enough power to do that. And guys, this kind of stuff, is consistent with all tests. If we go in F test, and let's say we want to do just a one-way ANOVA, so we're not doing a two-way or three-way, and we want to come up and do some post hoc, hit your determine, and the easiest way to do this is if you have the means for the groups, and so number of groups. seems like there's a way that, yeah, so we can, let's say we only have 3 groups, so we can do that over here. Standard deviation of the within each group, so that would be the within each group, standard deviation sigma within each group. So that sounds like that would be the sum of squares within. So that's going to be the sum of squares for the error. We're looking at equal in. So, you know, everything else is pretty clear. All right, gang, just wanted you to have that on your radar of how we need to do that. So, guys, again, keep in mind here, this effect size is using the effect size f. And so if you calculate r squared or something else and put that value there, you'll get a wacky power. That's not appropriate. Okay, enough of that, and you know we'll learn as we go. It's all good. All right, guys. I think the third thing on the agenda was assignment number 2. The new stuff that we're going to be studying in assignment number 2 over, I think it's over 3 weeks. First of all, we're looking at nonparametric designs. And the only thing that I'm really wanting you to look at here is the equivalent of a 2-sample independence t-test. So I want you to look at the equivalent of that, and I also want you to look at the equivalent of ANOVA. So what happens if our assumptions are severely violated? What do? Well, we run some sort of nonparametric. And when I think of nonparametric, I don't really think as much that I've got a quantitative variable and I look at, oh, that reminds me of something else, a quantitative variable, and I do a distribution shape and I get a positively skewed distribution. I don't really think about that as much as I do maybe taking information from a Likert Scale. Now, I think you guys probably know Likert Scale. We do from like a strongly disapproved to a disapproved to neutral feelings to approve to strongly approve. In statistics, what we typically do is we give these things, these responses, values of 1, 2, 3, 4, and 5, and we do these over items, and we sum these things up, allowing us to do item analysis, and we also do look at the the sum of the responses. Well, there's no reason to think that a Likert scale would be normally distributed. I mean, it's first of all, it's not even a quantitative variable. We quantify it by giving these 1, 2, 3, 4, and 5s to these values, but it's not going to clearly not going to be a normal distribution. So when I think of nonparametric, again, I don't think as much about a violation of the assumptions by running the running Shapiro and Levine's test of equal variances. It's something to me that when I set up the design of the study, it's clear that I've got a variable that isn't naturally quantitative. I would call this falsely quantitative because we created that design. We gave those numbers. I could have given 0, 1, 2, 3, 4, or I could have given it 7, 8, 9, 10, 11. But I chose 1, 2, 3, 4, 5 just because it's standard. One more thing, assignment number 1, I just remembered something. Here's where a lot of you are probably one of the biggest mistakes. When you do a 2-sample t-test, and this was even some of the better students. I don't mean better in terms of, but I just mean the people who seem to be getting this easier than some of the others. You even did this. The first thing you're going to run into, hopefully I haven't lost you by now because I'm actually telling you the most important thing in the video right now. The first thing you run into is, do I run a pooled or unpooled test? And what some of you are doing is you're going in and you're conducting Levene's test of equal variances. And you're making your decision based on this result. Guys, that's wrong. It's totally wrong. And I pointed that out in the video. When you make, let me explain to you why that's wrong. Let's say, for example, that we run a Levene's and we get a p-value of 0.03. Now, what's that tell you? Well, that tells you we're going to reject the null and conclude that the population variances are not equal. That's fine, because that's going to lead us into running an unpooled test, which we needed to do anyway. But what happens if we get a p-value equal to 0.25? Well, then we would fail to reject H sub O and conclude what? That we have equal variances? No, that's not what we conclude. When we fail to reject the null, we're saying that the evidence from the sample can't reject that statement. It doesn't mean that statement is true. In fact, your null hypothesis is never true. I mean, think about a large population and the likelihood that we could go into a large population. Let's call this population number 1. N has 15 million people. And population number 2, N has 22 million people. And we go in and we magically can find the means. What is the likelihood that we get this mean over here and that's exactly what we get over here? Pretend those are the same numbers, okay? It's not going to happen. That's not what we're all about. When we look at, for example, there's a lot of emphasis put on gender biased tests like our standardized tests like ACT and SAT being gender biased. So we would like to test whether the mean for males is the same as the mean for females against the mean for males not equal to the mean for females. And let's just pick on ACT here. Think of all of the males that have taken the test over the time period they want to examine and all the females that have taken the test. Do you truly think that those means down to the 100th digit past the decimal point are going to be the same? Absolutely not. But if you ran this, it turns out that you get a very high p-value, which leads you to reject, leads you to fail to reject and conclude that there's no evidence from your sample to reject the claim that the means are equal. You don't walk away saying that the means are equal. You walk away saying that there wasn't enough evidence to reject that claim. And the SAT folks can say, well, there's no evidence to indicate that there's a difference in mean ACT scores across gender. That's the kind of terminology we use. So guys, when you use H sub O in Levene's test, if you just have two populations, and you fail to reject, it doesn't mean these things are equal. It just means there's not enough evidence from your sample to reject that claim. So guys, at the end of the day, what do I want you to do? I want you to always report an unpooled two-sample t-test. The only time that I think it's appropriate to run a pooled t-test, in which case you get more power, slightly more power, not a lot, but you get slightly more power because of the way that the standard error is calculated. The only time, again, you wouldn't run the only time you would run a pooled t-test is when there is theoretical evidence that the population variances are the same. There have been extensive studies. There has been, maybe in the design, the way things, maybe an exam has been normed out, that the population variances are equal because of the design, not because of natural variation. So when is that going to happen? in my opinion, probably almost never. So guys, when it comes down to pool or not to pool, I always want you to run an unpooled 2-sample t-test. Okay? We get into the pooled stuff, once we generalize this process and get into ANOVA, as we've seen. All right, gang, that's it. Have a good one. Take care. Bye.